What's up, Chem peeps? Who's ready for some free response? A student performs a series of reactions involving copper to study the process of oxidation and reduction. Redox. In the first reaction, the student heats a sample of copper powder in an open crucible with a Bunsen burner and observes the characteristic color of the copper sample change to black. The copper sample reacts with oxygen in the air to form copper 2 oxide as the only product. The data collected in this experiment is provided below. Boom! Part A. Write a balanced chemical equation for the reaction that occurs. We're reacting copper powder. Boom! S for solid. Reacts with oxygen in the air. Boom! G for gas. To form copper 2 oxide. Boom! Don't forget your nomenclature. Alright, now that I've got my formulas for everything, let's make sure this equation is balanced. We've got 2 oxygen on the reactant side, only 1 on the product side. Coefficient of 2 will bring balance to my oxygen. Then I need another coefficient of 2 in front of my copper. Balanced. Common errors. Forgetting that oxygen is diatomic. Forgetting what the Roman numeral 2 means in copper 2 oxide. Don't make those mistakes. Subpart I. Does the equation represent a redox reaction? Justify using oxidation states. Easy. I'm going to write my oxidation states above each of the elements in the equation. Copper, 0. It's a free element, neutral. Oxygen, oxidation state of 0. Free element, neutral. My ionic compound, oxidation states are going to match the charges of the ions. Oxygen's going to be -2, copper +2. Answer: yes. The reaction represents a redox reaction. Let's justify. Copper is oxidized from an oxidation state of 0 to an oxidation state of +2. It has lost electrons to go from an oxidation state of 0 to +2. Oxygen is reduced from an oxidation state of 0 to an oxidation state of -2. Oxygen must have gained 2 electrons to go from the oxidation state of 0 to -2. Remember our good friend Leo and what he says. Grr. Subpart II. Compare the mass of the copper sample before heating to the mass of the copper 2 oxide after heating. Does this reaction violate the law of conservation of mass? Explain. Alright, let's head up to our data table to check this out. Notice that the mass of the copper sample and crucible, so copper and crucible only, 35.76 grams. The mass of copper 2 oxide and crucible after, 35.84 grams. We've gained some mass. The law of conservation of mass is a lie. Boylan, you're a liar. Pants on fire. Nay. Let's think about this reaction. It's happening in an open crucible, and it's reacting with the oxygen in the air. So let's answer this. The reaction does not violate the law of conservation of mass. Answer. Let's explain. The added mass comes from the oxygen in the air that copper reacts with to form the compound copper 2 oxide. Boom. In another set of reactions, the student fills 2 test tubes with a solution of aqueous copper 2 nitrate. In the first test tube, the student places a small piece of solid silver. In the second test tube, the student places a small piece of solid zinc. The student only observes a chemical reaction in one of the test tubes. Which one could it be? Part B. Write a balanced chemical equation for the reaction that occurs in the test tube in which the student observed the chemical change. What the? How am I supposed to answer this question? How am I supposed to know? Do I look like a genius? To answer this question, we need to refer to our activity series. Boom. Zoom in here on the metal portion of this. Boom. Now, we're reacting copper 2 nitrate. There's that nomenclature again. And it's reacting with either silver or zinc. Only one of them causes a reaction. Coming back to our activity series. Copper is here, silver is beneath it on the activity series, zinc is above it. Recall that your activity series lists the metals in order of reactivity. Most active on the top, least active on the bottom. And in a single replacement reaction like the one we're performing, the metal can only replace a metal in a compound that is beneath it. So zinc sure could replace copper, silver, no way. So zinc's our winner. Single replacement. The zinc, it's gonna kick the other metal out, and it's gonna form a compound with nitrate. Now be careful, zinc is one of those few exceptions of transition metals that don't have a Roman numeral. You just have to remember that zinc forms the +2 ion. So once again, nomenclature never going away. Ever. Now, the nice thing about this is it's already balanced with coefficients of 1. Winning. Subpart I. Provide one additional metal solid in which a chemical reaction would be observed if it were placed in a solution of copper 2 nitrate. Easy. Anything above copper would work. Anything above copper would replace it in a compound of copper 2 nitrate. I'm gonna choose my personal favorite, sodium. But you can choose any of these up here and still be correct. Just make sure it's above copper on the activity series. Sodium, because I'm sodium funny. Have a fantastic day.